Dear fellows, I'm Tianqi from the Apache DolphinScheduler community. Today I'm going to introduce the next generation big data scheduler, DolphinScheduler, to you, and to share the evolution of the DolphinScheduler architecture. Today we are going through it from 4 aspects. First, introduce the introduction of DolphinScheduler. Second, talk about the pain points that DolphinScheduler solves. And then about DolphinScheduler community. At last, about the advantages of DolphinScheduler. So, what is DolphinScheduler? Apache DolphinScheduler established it at Analysis Inc. in 2017, being open source in March 2019, and joined Apache Incubator in August 2019. Over 400 companies has used the DolphinScheduler in production. DolphinScheduler is a distributed and extensible workflow scheduler platform with powerful direct acyclic graph visual interfaces dedicated to solving complex job dependencies in the data pipeline and providing various job types available out of the box. From the picture we can see DolphinScheduler solved many pain points in scheduling. We can see that Visual DAG enables you to visualize task operate status in real time, and high availability supports task operation like retry, recovery failure from specific node, suspend, and queue. About compatibility and extensibility, the system supports multi-task types. Then we move to the developed background of DolphinScheduler. So, why is DolphinScheduler here? Why we made it? The first point is, in 2017, there wasn't any visualized DAG drag and drop scheduler, and we hope there will be one, with the simple, easy features and low barrier of learning. The scheduler that not restricted to programmers, but also data analysts could easily use. And the second, we need to consider various system exceptional scenarios due to the scheduler system as an important part of the infrastructure of the whole system. High availability, high stability are what we concerned. And we coping with fault tolerance, failure retry, rollback, failover when system failure. And the third point is, we support various task types and provide powerful extensibility. We support tasks include shell, data source, Spark, Flink, MR, Python, HTTP, child process, and task dependency. And we also support high extensibility plugins mechanism, and by this, you could easily customize your own task plugins. The fourth point is about task dependency. Workflow scheduling is the most important point of the scheduler system. Not only about task self-dependency itself, but also about interact dependence between workflows. And this is a feature where the big data system differs from normal system. The fifth is about alert mechanism, which is far important point of different systems. We need to trigger alert in time when different exceptions occur and we provide several alert mechanisms. And the last one is complement, which means we could make remediation when exception occurs and rerun tasks. After open source about 1.5 years, DolphinScheduler is featured with high extensibility and stability, and especially with an active community. It gains good recommends inside the user group. Over 400 companies use DS all over the world, like Tencent, IBM, Walmart, Nokia, Lenovo, etc. And about our belief and principle. DS follows the Apache way as an abiding belief and insists the principle of community over code. Currently, we have over 200 contributors. 170 contributes code and 50 in documentation. And of course, there are still some colleagues maintain our social accounts and organize activities. The community eagerly welcomes any form of contribution you could participate in with any position, whatever the formation, about code or organizing activities, documentation, publicity, or just IT skills sharing. And all of this helps the development of the community and make it booming. And here's advantages about DS. The first is reliability. We implement decentralized multi-masters and multi-workers in architecture design, which supports high availability, and provide overload protection based on queues that won't cause system crash due to overload. We also support different load balancing algorithms according to different scenarios to ensure the server in a healthy condition. And the second is easy leads to nice. DAG, monitor user interfaces. Every workflow definition are all visualized and provides APIs, which enables interactions to third-party systems. All in all, we hope we could provide a simple and easy product to users. As mentioned before, we support task suspend and recovery, multi-tenants, and various task types, coping with rich big data scenarios. The last one is high scalability, support customized task type, and distributed scheduling enables capability linear growth by cluster extending. Now we talk about visualize the workflow. In the first picture, we could finish workflow arrangements by simply drag and move. Let me give brief introduction to the child process reuse. For example, from one layer of data warehouse to another layer, we could reuse the data in this way. As workflow arrangement designed in this way, user interfaces are created independent and clear to avoid display over 1,000 tasks inside one workflow. The second picture shows the operation status of workflow. And next, we could see history process data in the third picture and checking the overall and each running status by the Gantt chart. We integrate Apache Ambari enables you directly check system running status, and of course, DS also provides its own monitor functions. By comparing, Ambari could display matrices comparing DS own monitor function. Next, we move to multi-granularity task monitoring. The first picture shows the index page of the project, and we could see the pie chart of task status. And we can click into any task status to check process instance list or task under the specific status. The second picture shows the list. In the third picture, displays the traceback of task status. You can check the status history in the timeline by list function. The last one shows the logs of the task. You could see the task execution information in details by reading the log. In the recent years, native cloud ecology is booming. Compatible with native cloud has been a necessary ability of big data product. In this domain, DS has already taken the lead in supporting native cloud. We have done several Docker images and released 1.3.5, which made many updates. You can copy the image from official repository. That's the end of the introduction. Thank you all. Appreciate it. See you soon.